So when we're studying rates of change, the first thing to think about is a linear relation. So a linear relation, or a line, we know that we can pick 2 points and we can find the average rate of change between those 2 points, which we also have called the slope. And that slope stays the same between any 2 points that I pick on the line, because you're doing the rise divided by the run, and it stays constant. That's what makes it a line. That doesn't hold for curves. So that's the first thing we want to make sure that we understand, is that if a function's not linear, the average rate of change will not be constant. If the average rate of change connecting 2 points x1, y1, and x2, y2 is on a curve, so we pick 2 points, and the line that we connect them with is called a secant line. And if I pick 2 different points, the slope of that line will be different because it's not linear. So we call the slope of these secant lines the average rate of change. And the good news is the average rate of change is calculated as the slope. So the slope of the secant is just rise over run, or the change between the f at x values, the y values, over the change in x. The instantaneous rate of change is a little bit trickier. When we have a curve and we pick a single point called a point of tangency, and we draw a line touching the curve at just one point, that is called a tangent line. And that's a lot harder to deal with, because how do we find the slope of a line where we only have one point? We don't know the other point on the line. Well, what we have to do is we have to take a secant line that we do know how to find the slope of, or the average rate of change for, and I'm going to draw a secant line from one point that's pretty close on either the left side or the right side to the given point. And I'm going to find the slope of that line, and then I'm going to move my point a little bit closer to the given point, and I'm going to calculate the slope again. And the limiting value of all those slopes will be the instantaneous rate of change, or the slope of the tangent. So the limiting value is really important here, and this is going to be important for calculus. A limit is a value that the function's approaching. In this case, we want the limiting value of the slopes. So what value are the slopes approaching as the change in x gets smaller and smaller and smaller, or approaches 0? So let's look at an example. For this parabola, c of n equals 2.3n squared minus 66n plus 720. N is the number of minutes of the truck is running, and c of n is the cost of operating a cement mixing truck for n minutes. We know that this is a quadratic, or a parabola if we drew a graph, and we know that it's not linear, so the average rate of change between 2 different points will be different. So between 0 and 3 minutes will be different than 3 and 6 minutes, will be different than 15 and 18 minutes. So we're just going to calculate, just to practice this idea, the average rate of change between 3 and 6 minutes. And this should be pretty easy because we've actually done this before in grade 9. So if n equals 3, what's c at 3? Well, you're just going to substitute in 3 into our equation, and we will get 700 and nope, we're going to get 542.70, and then we'll do the same thing. We'll figure out what c at 6 is by substituting in 6. So 2.3 times 6 squared minus 66 times 6 plus 720. So we know our two n values, and we know our two cost values, or y values. So our slope of the tangent, or our average rate of, or not of the tangent, sorry, of the secant, or our average rate of change, because we're talking about average first, This is the slope of the secant. So that's just the line that we're drawing between those 2 points on our curve, is just c at 6 minus c at 3. So you just put those values in, whatever you get for c of 6 minus c of 3, and then divided by the change in n, which would just be 3. And you should end up getting negative 45.30 per minute, so dollars per minute. Remember, a rate has units of something per something because it's a rate of change. Okay, so at that region, in that region of the graph between n equals 3 and n equals 6, you're going to have a negative rate of change, which means that the line that I'm drawing is decreasing, or it's pointing downward as you travel left to right for that portion of the graph. Okay, now we were asked to find the instantaneous rate of change. So for this, we need to set up a table. And what's important here is to remember that we're just finding slopes of secants with values very close to the given value. So it's said in the question for part B, find the instantaneous rate of change after exactly 3 minutes. So 3 is going to stay the same, but I'm just picking values that are close to 3. So 3.1, 3.01, 3.001. And in the other side, I could pick 2.9 is close, 2.99 is even closer, and 2.999. So for the purpose of this course, I would like you to either pick 3.1, 3.01, 3.001, or 2.9, 2.99, 2.999. Now we could check both, and that's probably better, but all you have to write down for me is just on one side. So we're going to the right of 3, and we're picking 3 values. And that's what I'm expecting to see, is at least 3 values in our chart. So when I put those back into C, I'm just putting 3 in for C, or for N, so C at 3, and then I'm putting C at 3.1, and I'm subtracting them, okay? So I think I actually started with C at 3.1, and I want all the decimals here, so 537.508, so you're just going to plug that into your calculator. You can store it in your calculator or save it. Oh, sorry, it was 503. You need all your decimal places somehow, though, please. Minus C at 3 was 542.70. And the change in n is 0.1. So when I divide delta C by delta n, I end up with negative 51.97. Now I'm going to do C at 3.01 minus C at 3, and I'm going to get 542.17823. It'll be tempting to round, but we should not. And C at 3 always stays at 542.70. Now our change in n, or delta x, right, is 0.01, and we end up with negative 52.18. Okay, so if you don't want to write down all the decimals, you need to at least store it in your calculator. 542.6478023 is C at 3.001, minus again 542.70. So you could just write down the final number. You can show me the individual C values like I did here. I'm not picky about that, but I need at least 3 entries organized in a table that looks like this. 0.01 is my change in n, and my final slope value is 52.1977. So all I did was I just calculated a bunch of average rates of change where the value, the change between the first n value and the second n value is very small, and it gets smaller as we go down the table. So what we say for our conclusion is that as delta n goes to 0, so the change in n goes towards or approaches 0, the limiting value of the average rates of change is, and then from there we're going to look at the last entry to see what pattern emerges. So it looks like it went from 51.97, almost negative 52, to negative 52.18 to negative 52.1977. So that is actually approaching negative 52.20. We're talking about money, so I'm going to round to the 2 decimal places. If you're uncomfortable doing that, you could always just use the last entry here. and that's dollars per minute.